Hello viewers, in today's class we are going to solve one more important and conceptual problem from definite integrals involving greatest integer function, right? So here we have this problem, that is we have to find the value of this integral from log of 2 to log of 3, 1 over e raised to x, then log of greatest integer of 1 plus e raised to x, right? So here the symbol ln implies the natural log of given number, right? So let us start. Now here let us first take this integral as I, right? So here we'll adopt the method of substitution to solve this type of problem, and see here we have the greatest integer function inside this natural log, right? So what we will do, we'll take this expression, that is 1 plus e raised to x, as t, right? So t is equal to 1 plus e raised to x, so therefore we have dt over dx is equal to e raised to x, right? So now we can replace e raised to x by t minus 1, right? So from here e raised to x is t minus 1, so substituting it over here, we have dt over dx is equal to t minus 1, right? So now we can write dx is equal to dt over t minus 1, right? So for dx we have this expression, that is dt over t minus 1, right? Now see here the values of x varies from ln2 to ln3, so we'll convert these limits as we are converting this integral from variable x to variable t, right? So let us change the limits. So when x is log of 2, then the value of t is given by this expression, that is 1 plus e raised to x. For x we have log of 2, right? And we know that e raised to log of p is always equal to p, right? So we'll apply this rule to evaluate this expression. So we have t is equal to 1 plus 2, because for p we have 2 here, so e raised to ln p is equal to p, so we have 1 plus 2 is equal to 3, right? Now when x is log of 3, then the value of t is 1 plus e raised to ln 3, right? So here we'll take x is equal to log of 3, and again applying this rule to evaluate this expression, we have 1 plus 3, that is 4, right? So when x varies from ln2 to ln3, then t varies from 3 to 4, right? So now let us express this integral in terms of t. So now we can write this integral I as integral from 3 to 4, and here we have 1 over e raised to x. So for e raised to x we can write t minus 1, right? So we have t minus 1, and then we have log of greatest integer of t, because for 1 plus e raised to x we have t, right? And for dx we can write dt over t minus 1, right? So now let us simplify it. So we have 3 to 4 log of greatest integer of t divided by t minus 1 square, right? So we can multiply these two factors to get t minus 1 square, and here we have dt, right? So now we have to evaluate this integral. Now see here t varies from 3 to 4, right? So when t varies from 3 to 4, then obviously the value of greatest integer of t must be equal to 3, right? So when t lies between 3 and 4, then the value of greatest integer of t is equal to 3. So here we can write 3. So now this integral I takes the form 3 to 4. We have ln of 3 and we have t minus 1 square dt, and we can take ln 3 outside this integral sign, because ln 3 is a constant. So we have ln 3 and 3 to 4 and dt over t minus 1 square, right? Now here we have a very simple integral, and we know that the integral of 1 over x minus a square dx is always equal to negative of 1 over x minus a, right? So we'll apply this formula over here. So integral I becomes log of 3, and we have a negative of 1 over t minus 1, right, due to this rule. So the integral of 1 over x minus a square is equal to negative of 1 over x minus a. We can also get this result by a method of substitution over here, by taking u is equal to t minus 1, right? But here we'll prefer to write the direct result for this result, right? So we have here the limits are from 3 to 4. So we have log of 3. Now substituting t is equal to 4 over here, we have minus 1 over 4 minus 1 is 3. Then we have minus, then we have t is equal to 3, so 3 minus 1 is 2, so we have 1 over 2, right? So now we can simplify it. So we have log of 3, here we have minus 1 over 3, then plus half, and if we simplify these two terms, we'll get minus 2 plus 3 over 6, and this is log of 3 times 3 minus 2 is 1 over 6, right? So the value of this integral is equal to 1 over 6 times the log of 3, right? So this is how we solve this type of problems.